This is the EdExcel GCSE 9-1 Maths Foundation Paper 3, which is a calculator paper and is from the Specimen Set 1 papers. Question number 1. We have to write 5,689 correct to the nearest thousand. Well, if I draw a number line, if we were to write this number correct to the nearest thousand, our answer will either be 5,000 or 6,000. And we've got our halfway point, 5,500. And then we note that our number is 5,500 or greater, and therefore what we would have to do is round up to the 6,000. So we have 6,000. Question number 2, we have to work out 30 plus 12, all divided by 5 plus 3. Well, on our calculator, if we press the fraction button and then type in 30 plus 12, and then on the bottom we've got 5 plus 3, we get 21 over 4, which as a decimal is the same as 5.25. Question number 3, we have to work out the reciprocal of 0.125. Well, what the word reciprocal means is 1 over. So we have 1 over 0.125, and if we work out what this is, equal to well, 1 over 0.125 is equal to 8. So our answer is 8. Question number 4, here is a list of numbers. From the list we have to write down, for the first part, a multiple of 4. Well, if we think about the 4 times table, we've got 4, 8, 12, 16, etc. The number which is a multiple of 4 will be 12. Then we have to write down a prime number. Well, a prime number has 1 in itself only as factors. So the possible options we could choose will be the 2 or the 5. I'm going to write down the 5. 2, by the way, is the only even prime number. Question number 5. There are 1.5 litres of water in a bottle. There are 250 millilitres of water in another bottle. We have to work out the total amount of water in the 2 bottles. Well, what we can do is convert the litres to millilitres. 1.5 litres, if I multiply that by 1000, I get 1,500 millilitres. And therefore, for the total, we have the 1,500 millilitres added on to the 250 millilitres. So the total amount of water is 1,750 millilitres. Question number 6. Here is a trapezium. This diagram is drawn accurately. For part A, we have to measure the line of PQ. Well, if we were to measure the line of PQ, we've got 1, 2, 3, 4, 5, 6, 7.2. So we've got 7.2 centimeters. And then we have to measure the size of the angle marked X. Well, if we have our protractor, what we need to do is measure this angle, and you can see the angle is equal to 34 degrees. So we have 34 degrees. Question number 7. For part A, we have to solve f plus 2f plus f equals 20. Well, f plus 2f plus f, that will be 4f. 4f is equal to 20. And then if I divide both sides of this equation by 4, what you will find is f is equal to 20 divided by 4, which is 5. F is 5. For part B, we have to solve 18 subtract m equals 6. Well, 18 subtract some number is equal to 6. That number then is equal to 12. 18 subtract 12 is equal to 6. For part C, we have to simplify d squared multiplied by d cubed. Well, what we would have to do here is add the powers. We have the same base and we are multiplying, so adding the powers, we have d to the power of 2 plus 3, which is the same as d to the power of 5. Question number 8. Jane writes down the following: 3.4 times 5.3 equals 180.2. Without doing the exact calculation, we have to explain why Jane's answer cannot be correct. Well, we've got this calculation, 3.4 multiplied by 5.3, and this is approximately equal to 3 times by 5, and 3 times by 5 is equal to 18. So what can we say then? Well, her answer is too large, which is why she cannot be correct. Question number 9. The two numbers a and b are shown on a scale. The difference between a and b is 48, and we have to work out the value of a and the value of b. Well, first of all, this difference is 48. Now we've got 1, 2, 3, 4, 5, 6 gaps, which represent 48. So one gap is equal to 8. So when we come to work out the value of a and b, well, here we've got minus 8, and here we would have minus 16. So the value of a is minus 16. Then we've got this 0. Then here we've got 8, 16, 24, and then 32. So the value of a and b will be minus 16 and 32 respectively. Question number 10. We have to complete this table of values. Well, when n is 12, what is the value of 3n plus 2? Well, I've got 12, and I need to multiply this by 3, and then add 2 to the result, and I get 38. Next, I'm given the value of 3n plus 2, which is 47. I need to work out the value of n. Well, if we create an equation, we have 3n plus 2 equals 47. Subtracting 2 from both sides, we see that 3n is equal to 45, and dividing both sides by 3, we see that n is 15. So we've got 15. Question number 11. the same number is missing from each box. Well, what we have to do for part A is find this missing number. Now we've got the same number, I times it by itself 3 times and I get 343. In other words, what I have is some number, we'll call it n, which is cubed. The result is 343. So we need to find out what n is. We've got this 343, which we need to cube root. And it turns out we get 7. So this missing number is 7. Then for part B, we have to work out 4 to the power of 4. Well, let's input that into our calculator. We've got 4 to the power of 4, which is 256. So we have 256. Question number 12. Here are two numbers, 29 and 37. Nadia says both of these numbers can be written as the sum of two square numbers. Is Nadia correct? You must show your working. Well, for the square numbers, we've got 1, 4, 9, 16, 25, 36, and then we could continue. So if I think about this 29 we can rewrite as the sum of two square numbers. We can write 25 as 4 plus 25. 4 is a square number, 25 is a square number. And this 37 we can write as the sum of 36 and 1. 36 is a square number, 1 is a square number. And therefore, from these two statements, what we can conclude is Nadia is correct. Question number 13. Here are the first three terms of a sequence. We've got 32, 26, 20, and we have to find the first two terms in the sequence that are less than 0. So, we start off with this 32, then we go to 26, then we go to 20. What do you notice? Well, each time we subtract 6. So if I subtract 6 once again, I get 14. If I subtract 6 once again, I get 8. If I get 8 and I subtract 6 from it, I get 2. Then if I subtract 6 from this, I get minus 4. Minus 4 is less than 0. And if I subtract 6 from this again, I get minus 10. Minus 10 is less than 0. Question number 14. Here is a triangle ABC. For part A, we have to mark with the letter Y the angle CBA. So we need to represent the angle CBA with the letter Y. That is over here. Next, here is a cuboid. Some of the vertices are labelled. We have to shade in the face C, D, E, G. Well, here is it shaded in. Next, we have to see how many edges are there in this cuboid. Well, let's just count. We've got 1, 2, then we've got 3, 4, 5, 6, 7, 8, and then we've got 9, 10, 11, 12. We've got 12 edges. Question number 15. There are 5 grams of fibre in every 100 grams of bread. A loaf of bread has a weight of 400 grams. There are 10 slices of bread in a loaf. Each bread slice has the same weight. We have to work out the weight of fibre in one slice of bread. Well, a loaf of bread has got a weight of 400 grams and there's 10 slices in a loaf. So if 10 slices has a weight of 400 grams, that would mean one slice would have a weight of 40 grams. So, what do we know? We know that there are 5 grams of fibre in every 100 grams of bread. So, what we need to do is find out how much fibre we have in one slice. And in one slice we've got 40 grams. So, writing out what we know, we've got 5 grams of fibre in 100 grams of bread. So that would mean 1 gram of fibre would be in 20 grams of bread. Now what we have is 40 grams. And if I multiply by 2, that would mean we've got 2 grams of fibre in 40 grams. Question number 16, we have to give an example to show that when a piece of cut off a rectangle, the perimeter of the new shape for the first part is less than the perimeter of the rectangle. Well, what we can do here is cut along here. So let's just draw some scissors. If I cut along here, I would end up with this rectangle here. Now we want something which is the same perimeter of the rectangle. Well, what I can do is cut along here and then here. And if I do that, I would end up with this shape here. Then we want something which is greater than the perimeter of the rectangle. Well, if I cut down here, then back up here, so let's just draw some scissors, then what we will end up with is, we end up with this shape here. Question number 17, ABC is an isosceles triangle. Well, angle A is 70 degrees. There are 3 possible sizes of angle B. What are they? Well, here's one possible triangle where AB equals AC. Here's another possible triangle where AC equals BC. And here's another possible triangle where AB is equal to AC. And in each of those cases, we've got the angle A, which is 70 degrees. Now, if I do 180 take away 70 and then divide by 2, that would mean this angle's 55 and this angle here is 55. We've got an isosceles triangle. Base angles in an isosceles are equal. And we've also got this other situation. What I could have here is this angle being 70 degrees. Then 180 take away 70 take away another 70 will be 40. So this angle here could be 40 degrees. Or we could have the 70 here. We could also have the 70 here. which would mean this angle here is 40. So what you can see then is there are different possibilities for the angle B. We've got 55 degrees, we've got 70 degrees, and we've also got 40 degrees. Next, when the angle A is 120 degrees, we have to explain why there is only one possible size of angle B. So the angle A must be the largest angle. That's because ABC is isosceles, which means that the two angles cannot be 120 because angles in a triangle are up to 180. So there's only one possible angle for B. That's 30 degrees. Question number 18. In a breakfast cereal, 40% of its weight is fruit, the rest of the cereal is oats. You have to write down the ratio of the weight of fruit to the weight of oats. Give your answer in the form 1 to n. So, we have fruits to oats. We've got 40% fruit, which means we would have 60% oats. And if I divide both sides by 40, then we will end up with 1 to 1.5. So the ratio is 1 to 1.5. Next, a different breakfast cereal is made using only fruit and bran. The ratio of the weight of fruit to the weight of bran is 1 to 3. What fraction of the weight of the cereal is bran? Well, we've got 1 plus 3, which is 4. So we've got 4 parts in total, and of those, 3 of them is bran. So the fraction is 3/4. Question number 19. Boxes of chocolate cost $3.69 each. The shop has an offer. Boxes of chocolate, we get 3 for the price of 2. Ali has £50. He is going to get as many boxes of chocolate as possible. How many boxes of chocolate can Ali get? So, first of all, if we get 3 for the price of 2, that means that the offer cost is equal to 2 times by $3.69, which is $7.38. So we get 3 boxes for $7.38. So what can we do? Well, what we can do is find out how many boxes we can get given with this £50. So if I do 50 divided by 7.38, well, I would get 6.77, etc. boxes, which means that we require 6 lots of 3 boxes. So we know that 6 lots of 3 boxes equals 18 boxes. And let's find out the cost of this. So I've got 3 boxes which cost $7.38, and what I have is 18 boxes. So what I can do is find out the cost of this by multiplying by 6. So 738 times 6 is 44.28. So you can get 18 boxes and you will pay £44.28. So therefore, if I do 50, take away the 44.28, I get £5.72, which is remaining. Now one box would cost £3.69, so we can get one more box because I still would have enough. So if I've got £5.72 and take away £3.69, I get £2.03 remaining, so I can still get one more box. So I would have 18 plus this extra 1, which is 19, so I can get 19 boxes. I've got 18 boxes plus this extra one more box I can get, which gets me 19 boxes. Question number 20, we've got a set of numbers 1 to 10. A is equal to multiples of 2. A and B is 2 and 6. A or B is 1, 2, 3, 4, 6, 8, 9 and 10. We have to draw a Venn diagram for this information. So here is our Venn diagram. We've got A and B. Now we know that A and B is 2 and 6. So we've got 2 and 6 for A and B. So the multiples of 2, we would have 2, 4, 6, 8 and 10. Now the 2 and the 6 have already been used up, so what's left over will be the 4, the 8 and the 10 in A only. So let's cross those out. And what will go in B? Well, I've already used the 2, I've already used the 6, I've used the 4, I've used the 8 and I've used the 10. So what goes in B only will be 1, 3 and 9. And what's left over is, well, I've got the 1, the 3 and the 9, which have been used up, and then I've got the 5 and the 7 remaining, so those go on the outside. So here's the completed Venn diagram. Question number 21. The scatter diagram shows information about 10 students. For each student, it shows the number of hours spent revising and the mark the student achieved in the Spanish test. One of the points is an outlier. We have to write down the coordinates of the outlier. Well, an outlier is one of those points which looks like it doesn't follow the general pattern of the other points. Now, all these points look like they follow a straight line, apart from this point. So that point is the outlier. It has coordinates for 10. For part B, for all other points, we have to draw for the first part a line of best fit. So if I were to draw a line of best fit, we would have something looking like this. It goes through as many points as possible. We want roughly the same amount of points above the line as we have below the line, as we see here. And then we have to describe the correlation. Well, as the hours spent revising increases, so does the mark. So what we have is a positive correlation. Then a different student revised for 9 hours. We have to estimate the mark the student got. So they spend 9 hours revising. As we see here. And the mark they would get will be 63. Then the Spanish test was marked out of 100, and Lucia says, I can see from the graph that if I'd revised for 18 hours, I would have got full marks. We have to comment on what Lucy says. Well, if I take a look at the points I've got, what I can see is 18 is outside the dataset. The comment may be unreliable. Question number 22. The length L of a line is measured as 13 correct to the nearest centimetre. We have to complete the following statement to show the range of possible values of L. Well, the lower bound will be 12.5 and the upper bound will be 13.5. So here is the error interval. Question number 23. The line L is drawn on this grid. We have to find the equation of L in the form y equals mx plus c. Well, what we need to do to begin with is find the gradient of the line. So if I pick 2 points, for example, this point and this point, I can see that my change in y is 2, but my change in x is 1, and therefore my gradient is equal to 2 over 1, which is 2. And my y-intercept over here is 1. So my y-intercept equals 1. So for my equation of the straight line, I would have y equals gradient 2 x plus 1. Question 24. Jenny works in a shop that sells belts. The table shows information about the waist sizes of 50 customers who bought belts from the shop in May. And for part A, we have to calculate an estimate for the mean waist size. Well, first thing we need to do is find the midpoints of each of these intervals. Here we've got 30. Here we've got 34. Here we've got 38. And here we've got 42. Now what I need to do is work out the midpoint times the frequency. So 30 times 12 is 360. 34 times, rather, here I've got 24, so here I've got 720. 34 times 12 is 408. 38 times 8 is 304. And 42 times 6 is 252. Now, if I add together all the frequencies, I would get 50. And if I add together all of this, well, 720 plus 408 plus 304 plus 252, I would get 1684. So the mean that would equal 1684 divided by 50, which is 33.68. So I get 33.68 inches. Then belts are made in sizes small, medium, large and extra large. Jenny needs to order more belts in June. The model size of belt sold is small. Jenny is going to order 3/4 of the belts in size small. The manager of the shop tells Jenny that she should not order so many small belts. Who is correct, Jenny or the manager? You must give a reason for your answer. Well, the proportion of small belts, we have 24 out of 50. So I've got 24 out of 50. And what this is approximately equal to is 1/2. It's almost equal to 1/2 because 25 out of 50 is a half, and this is quite close to 25. And this does not equal the 3/4, which she said she's going to order. She should actually order about half the belts in small. So, in this case, the manager is correct. Question number 25. The diagram shows a wall in the shape of a trapezium. Karen is going to cover this part of the wall with tiles. Each rectangular tile is 15 centimeters by 7.5 centimeters. Tiles are sold in packs. There's 9 tiles in each pack. Karen divides the area of the wall by the area of a tile to work out an estimate for the number of tiles she needs to buy. For part A, we have to use Karen's method to work out an estimate for the number of packs of tiles she needs to buy. So, first of all, here we've got centimeters and here we've got meters. We can multiply each of these by 100 to convert to centimeters. So here I've got 180 centimeters. Here I've got 270 centimeters, and here I would have 80 centimeters. So now we can find the area of the wall. For the area of the wall, well, we've got a trapezium, so the area here is going to equal 1/2 multiplied by 180 plus 270 multiplied by 80. So 180 plus 270 times 80 times 1/2 is 18,000. So I get 18,000 centimeters squared for the area of the wall. The area of the tile, we've got 18,000 divided by, well, first of all, the area of the tile is 15 times by 7.5, which is 112.5 centimeters squared. And therefore, if I do 18,000 divided by 112.5, we get 160. So 160 tiles are needed. And what we need to do is find out how many packs we need. Now we know that there's 9 tiles in each pack. So therefore, if I do 160 divided by 9, let's work this out. I get 17 and 7/9. So I get 17 and 7/9, which means I need 18 packs. So I need 18 packs. Now, for part B, Karen is advised to buy 10% more tiles than she estimated. Buying 10 more tiles will affect the number of tiles Karen needs to buy. She assumes she will need to buy 10% more packs of tiles. Is Karen's assumption correct? You must show you're working. So, if I buy 10% more packs, well, I said previously I need 18 packs, and if I multiply this by 1.1, I get 19.8, which means I need 20 packs now. And so, what we need to do is verify that we get 10% more packs. So if I get 10% more tiles, then I've got 160, which I worked out from here, multiplied by 1.1, which is 176. So I need 176 tiles. And therefore, knowing that there's 9 packs in each tile, I need to do 176 divided by 9. So if I work this out, I get 19 and 5/9. So I get 19 and 5/9, which is approximately 20 packs. And that's what we saw here. We require 20 packs in, which is 10% more packs, and therefore she is correct. Question 26, we have to factorise x squared plus 3x minus 4. Well, here I require two numbers which multiply to give 3 and which add to give minus 4. You will find those two numbers are 4 and minus 1. So when I come to factorise, I would have x plus 4 multiplied by x minus 1. So I've got x plus 4 times x minus 1. Question number 27. Here are the equations of 4 straight lines. We have 2 of these lines are parallel and we have to write down the 2 lines which are parallel. Well, what does parallel mean? Well, it means we need the same gradient. So if I've got y equals mx plus c, m is the gradient, so I need to rewrite each of these lines in the form y equals mx plus c. So if I take a look at A, I've got y equals 2x plus 4. If I take a look at B, I've got y equals, well here I need to divide by 2. So I've got 1/2 x plus 2. If I take a look at C, well, taking away 2x from both sides and then dividing by 2, we would have y equals minus x plus 2. And if I take a look at line D, I've got, if I rearrange, y equals 2x minus 4. Which ones have the same gradient? Well, A and D have the same gradient. So we've got A and D. Question 28. The densities of two different liquids A and B are in the ratio 19:22. The mass of 1 centimeters cubed of liquid B is 1.1 grams. 5 centimeters cubed of liquid A is mixed with 15 centimeters cubed of liquid B to make 20 centimeters cubed of liquid C. We have to work out the density of liquid C. Well, what we can do to begin with is find out the density of B. What we have already is the mass, which is 1.1 grams, and then we divide this by the volume, which is 1 centimeters cubed. So it turns out we get 1.1 grams per centimeters cubed for the density of B. Now what we can do is find out the density of A using this ratio. So for the density of A, well, if I've got this ratio A to B equaling 19:22, that would mean that A is equal to, well, the fraction A over B is equal to 19 over 22, which means that A is equal to 19 over 22 times by B. So the density of A is equal to 19 over 22 times by 1.1 grams per centimeters cubed. So if I work out what this is, I get 0.95 grams per centimeters cubed. So now that I know that, what I need to do is find out the mass of A and then the mass of B, from which I can find the mass of C. So if I know the volume of A, I know its density, I can find out the mass. So the mass of A is equal to the density of A, 0.95 grams per centimeters cubed, multiplied by the volume, 5 centimeters cubed, and it turns out we get 4.75 grams. The mass of B is equal to the density, 1.1 grams per centimeters cubed, multiplied by 15 centimeters cubed, and it turns out here we get 16.5 grams. So therefore, for the mass of C, we would have 4.75 grams plus 16.5 grams And it turns out here we get 21.25 grams. So then for the volume of C, what we would have is the 5 centimeters cubed plus the 15 centimeters cubed, and it turns out we get 20 centimeters cubed. And therefore, the density of C is equal to the mass, 21.25 grams, divided by the volume, 20 centimeters cubed, and it turns out we get 1.0625 grams per centimeters cubed.